So here we are back on lecture 12, relationships. That's one. And then we're in part 2. You can see we got some error bars on this graph, which are pretty much chosen by selecting chart, going up to chart design, over to add chart, going over to error bars, and more error bar options. Click out of that. And when you go in here, get more options again. We hit this, say okay, that's fine. Choose plus, down to the custom. You can see it's already picking it because it's specified. It's going to specify these deviations. Where we get the deviation, let's work backward. That's, there we go. After some practice, you can get this done. And we still need to fix this, but you get the idea from here to here, here to here, and here to here. Okay. So let me go back to this. I can go up here. One of these will work. This has changed a tad over the past couple of years. Option. There we go. Error bar options over here for different types. And that's what I'm looking for. We want only pluses and custom. You know, why that did this? There we go. That's going to do it. The minus will work. One of these will work, and we got it to work again. Okay, good. Now we have some error bars. These are the deviations. Where did we get the deviations from? Let's see where the deviations came from. They came from here, where we found spread minus predicted. What's the predicted? Alpha plus beta times D3. Okay. Just expanding our visual vocabulary here a little bit. We have that. We should probably also put a legend and an axis title down here. The axis title is simple. The name of the piece of data we used, and that was WTI. There we go. There we got a little bit better piece here. And then finally, press that plus. The legend, always put a legend on the bottom. And we have spread and predicted and deviation between them. And just to give you an idea of how things can work. We had already calculated the alpha and beta over here. The beta is the most important one because we get alpha out of it. And you can see it's the 0.829, almost 0.83, very high correlation. And that's why the error bars are so small in most places. Times the sigma of the spread divided by the sigma of the WTI. That ratio of the risk of the outcome spread divided by the input WTI. And what we're going to finish up with here is this. Market spillover. So we're going to say, suppose we go out and we observe a spread of $58 per barrel. Okay. And now we put it into our mix master here. We have two hypotheses, low and high WTI. That's our hypothesis. This whole piece is our hypothesis. Okay, our basic formation. But what the hypothesis implies is the rest of the story on the hypothesis, namely an average of 53 and 62 for the low and the high. The sigma is always going to be the same in a regression model. Sigma is a measure of these deviations. What is the average square deviation, square root of that, across the entire model? That's what sigma is measuring, and it's only $2.38. That's all per barrel. That's it. The distance between the actual data, which are these nice orange globes, and the blue regression line, the reason why it's not a straight line is the WTI is not exactly straight. So that's the reason for that. We get that, and notice how close it is. So that's the high correlation between the two. Okay, and what we have here is, suppose we go to work and we find, yeah, real high 72, yeah, fine. I remember 20 years ago we were predicting 100, and it finally hit that. The reason for it wasn't so much market, it was the wellhead cost itself, wellhead inflation, which impounds a lot of things. There's a lot of discovery costs. There's deep sea exploration, for example. There's a difference between a discovered and explored for reservoir and a producing reservoir. Reservoirs act like inventory. So how much inventory is there? And they're in containers, rock containers that could be porous. So all of these things end up being part of that wellhead inflation issue. That's why we might have a very high, aside from any other market disruptions, such as wars, terrorism, certainly, maybe even climate change. Climate change is producing famines in regions and wars, and it's a concatenation of a chaining together of several interlocking events. We have a WTI of 56 as a low. We could choose a different one. We choose 53. There we go. Try that. And a high of, I don't know, 81. Okay, from our analysis. We might have other analysis. Notice how things change pretty radically with regard to this. Now, if it's high, we're going to get a high mu too. Okay, or alpha of 22 and a 55 cent per barrel impact of WTI. So every dollar per barrel WTI gives us an impact of 0.553. That's what we measured from this particular data set. And that's the y-intercept, 22. So those things don't change, and neither does sigma. It's always going to be $2.38 per barrel for each situation. So if we observe $58, it's very likely that it's part of a high scenario. Why? Because of the way these two shape out. Now notice, that's what these odds say. But we know that we should be looking at the low and high. These things are practically the same. That's the one I would go for in this particular approach. Much better this way. Now, what are we looking at here with these 99, 99, and nearly 1, and 99.65, producing this pretty outrageous number over here, coming out of, oh my gosh, 40 times higher likelihood, still working 50-50 on either one of these. Of course, we're going to be getting very high proportion of the low versus the high. And that makes sense. 58 is closer to 51 than it is 67. That's kind of the idea here. And the low here, it's not really that favored relative to here. I mean, it's still, you know, I would say on this, they're almost even. On this, yeah, clearly one versus the other. We have two different things, two different ways to trade off. I would probably say we're close enough between 51 and 67. Say could be the high. Okay, so let's put this up closer to 61 and see what happens. Definitely, because 61 is much closer. Look at how this flipped down here. Okay, the spread less than 61 given the low. Does that make sense? Does that make sense? Spread greater than 61 given the high. Or is it the other way around? I think it's the other way around. Let's check this out. This does not make sense. This does make sense up here. Maybe we have a bad coding here. Let's check that. This is something we always have to worry about. I think it's going to be this, but let's draw the picture. Let's draw the picture. Let's be sure about this. I think we got a mistake. I think the analyst made a mistake there. Okay, so here's our spread. They're really spread mu's. That's really what they are. We have a low, we have a high. So here's the low, here's the high. The low and the high have roughly the same standard deviation. It should look just about the same. Sorry for that. And one more thing I want to put into this. I've drawn, here's the low mu, here's the high mu, and here's the sample. Here's what we observe with a spread. And suppose it's closer, a little bit closer to that mu, to the high. What we should observe is that triangle, that tail. It basically says this, the observation of the sample under the high hypothesis would be much greater than the sample coming in from the other side near the low hypothesis, which is this, triangle right here. Okay, okay, that's what we should observe. All right, now let's go back. What are the odds? Let's go back. Now that we have our principle in place. Okay, so here's a new situation. Just wanted to tighten it up a little bit. 53 and 63 are the WTI, low and high, kind of tight, giving us a 51-57 spread. Notice they're very similar to the size of the WTI. And that's because our prices are so high relative to that. Again, is that suppose we observe a 60 spread. There's that wedge, 88%. That wedge going up to 60 under the high, under that high piece is 88. The low is this, anything greater than 60 under the low is practically non-existent, which lines up with the low versus high being Okay, that 0.004 divided by 0.996 is nearly 0. Right, that's out. That's out. From a plausibility point of view, I think we would all agree with that. Okay, let's look at the picture again. There we go. All but 0.88 is that piece right there. Okay, so that lines up. That lines up. We have a mu low, a mu high, and our sample's kind of close to the high. That's what we should see. That's what we do see. Okay, so that makes sense. Going back to the model, suppose we saw, I mean, this should be outrageous, something bigger than 57, like that was 60 right there. That absolutely makes it. But let's take something a little less than 57, like 56. Okay, if we're on 56, yeah, definitely. Okay, so we're pretty much assured of that. Now, what else can we see here? What if we are down by 51? Well, we're in the opposite direction. The low is favored because we're very close and we're right on the mean of 51, and the odds are also consistent with that. We got that. Okay, so what can we say? And this is how we play with this. We try different pieces of this, different spreads that we might see, and examine which model would we pick. And we pick the model in which the higher plausibility here occurs. This is the low model in this case, which makes sense because 51 is very close to the low mean. If we had picked 56, for example, we could see the opposite, and we do. The high is preferred. The odds tell the same story, but so does common sense. We're almost right on top of the high mu. And that's that for hypotesting using the model, where now we've parameterized a low hypothesis versus a high hypothesis. We could use low, medium, and high as well in the same approach, and then look at where the spreads work out. From that point of view, we could have 5 different, which is a typical way many of the commodity companies operate, the 5 hypotheses about a fundamental factor, such as input crude for their refining business. The spread is what they're after here. Okay, so interesting stuff. Hope you found this interesting. We'll probably have one more line on this, looking at this again, but also looking at the credibility interval that exists inside this whole model. Well, until then, thanks very much for your kind attention, and be careful when you do these. Draw the picture. This was coded wrong, and it needed to be coded correctly. Okay, so watch out for that, and we'll see you on the next part. Thanks very much for I can feel your viewing pleasure. Take care.